All right, to finish up chapter 23 today, we're going to just jump right in and do a hypothesis test. Same story problem that we saw last time. Our coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. That's expected. Below are the amounts measured in a random sample of 20 cups. Is there evidence that the machine is shortchanging customers? Really important here, shortchanging. That means specifically we're looking, is the mean less than the 10 ounces that's advertised? Okay, that's really important because remember in hypothesis testing, we need to pay attention to that alternative hypothesis. Is it a less than, greater than, or not equal to? All right, so notice one more time that I have in my calculator, list 6, I have all this data listed. That's really important. I need to be able to use my data to answer the question. All right, so in hypothesis testing, step 1, the first thing I do is write hypotheses. My hypotheses this time are about mu. They're about the true mean. Okay, remember, mu represents the true mean coffee dispensed. By the way, this cute little thing is called the parameter. Right? Parameter. It's a true value of interest, meaning it's the thing we're looking for or we're interested in talking about. All right, in the null hypothesis, our HO, that's the value that we think mu might be if status quo, if nothing weird is going on. And that would be 10. This is the advertised value. The alternative hypothesis is what we're trying to prove. Well, if the machine is shortchanging us, that means we're wondering if the mean is smaller than 10. All right, there's my 2 hypotheses. In step 2, we check conditions. Very similar to what we did last time. Remember, we checked to see, is it random? As a matter of fact, yes. It says so in the problem. The other item we check is to verify that the data is nearly normal. Please remember that we do this by graphing our data. We need a nice little histogram. You must include a sketch of the histogram as part of your conditions. Don't just write yes. That will get you 0 points. You need to actually include a sketch. I just did that from memory, so forgive me if it's not perfect. You also need to comment on the sketch. Look, it's symmetric-ish, and it's unimodal. So roughly normal. Okay, that's good enough for us. Those are the 2 conditions that are met. We're going to be conducting what is called a one-sample t-test. Please ask me about that. That's important. Make sure I haven't forgotten to tell you. All right, step 3 is our mechanics. So just to kind of help you picture what's going on, we have this T model. It looks an awful lot like the normal model. As a matter of fact, the same things are true about it. The mean of this normal model comes, from our T model, comes from the null hypothesis, just like we did back in chapter 20. So this is going to be centered at 10. That's our mean. And the standard deviation that we're going to use is our sample standard deviation divided by the square root of the sample size. So I'm going to need my calculator to help me out with that just a little bit. And then I'm going to have some given value. I better pull up just a couple things from my calculator. I can simply calculate information about list 6. That would give me all the things that I need. That gives me my x bar and my s. gives me my X bar and my S. But I'm going to show you another place you can find them that I think might be just a little bit easier. So notice, we believe the mean should be 10 according to the normal model, but we didn't see 10. We saw 9.845. That's like down here, 9.845. And I'm wondering what's the chance that it's that or lower. So I could find a t-score. Get it? It's like a z-score, but it's t. So I do it the same way, 9.845 minus the mean of 10. And I'm going to divide by this SD. That's 0.198 over the square root of 20. Remember, 20 is my sample size, my n. And you can go through and put that in your calculator. And then you could use, instead of normal CDF, you could use TCDF. But again, I'm just going to show you my secrets and my shortcuts because I think you're ready. If I go to Stat and I go to Tests, I can do a t-test. Notice I have highlighted data. That's because I have a full list of data. This mu with a 0, that should be the value from your null hypothesis. So sure enough, ours is 10. It's found in list 6. And then this line right here is a place for you to indicate your alternative hypothesis. We did that we think it's less than 10. So I'm going to highlight that less than. And here comes all my answers. Notice X bar is right here. So if you want to copy it down from this location, you can plug it in your formula. The S that you need, it's also right here, and your N. So the things that you should make sure you pull out are the t-score and the p-value. So I'm going to go ahead and copy those down. I don't even have to do this in my calculator because I just copied down the answer. It's negative 3.49. And if I figured out everything in my calculator, I get that my p-value is about 0.001. So notice, it still looks like I've done everything. I've shown all my work, but I let my calculator just kind of take over. But I've still shown my work. Okay? This, it's a must. This, it's a must. Okay, you've got to have these things on your paper, even if you're letting your calculator find your final p-value. All right, one last item I'm going to add in right here where I wrote my t. Just going to indicate that I had 19 degrees of freedom. If you don't want to write this whole thing that I have here, just make sure somewhere off to the side you write that the degrees of freedom is 19. I wrote it also in blue. It's a must. Okay, you have to have the degrees of freedom. Must, must. All right, we're on to our last step. Since our p-value is 0.001, and we want to compare that to alpha. Whoa, Ms. Curtis, there was an alpha? Yeah, you might not have even noticed it. It's kind of hiding here. Back in the problem, I said, let alpha be 0.05. So that is lower than alpha. So that means we reject the null hypothesis. That means there is evidence that the machine dispenses less than 12 ounces of coffee. Notice this says less because our alternative was that it was less than 10. This agrees with our confidence interval that we did last time. Remember, that confidence interval did not contain 10. That's evidence that we're getting less than 10 ounces. All right, that's a hypothesis test. That's the whole shebang. We'll see you next time.